Today what we're going to do is work on taking a word problem and writing function from it. Assume the variations invest $12,750 to produce a CD. It costs $1.50 to make each copy. Express the cost of producing T CDs as a function of, there's a typo there, it should just say T. They sold each CD for $10. Express the revenue as a function of R. State the domain and range. Note, always define your variables. Part of that is done for us in the problem. Now, one of the things that we should do is figure out what are our variables. Sometimes people look at these problems and say, what is going on? If that's you, then what you need to do is kind of play with it a little bit, not trying to write the equation right away, but trying to see what's going on in the problem. How can I understand what's going on in the problem? How does changing something affect the numbers here? So for example, let's say I am only looking at cost right now, so we'll focus on that. And we say, what if I had I wanted to make 10 copies. How much would it cost me? Well, each copy costs $1.50. So I'd have to take $1.50 and multiply that by 10. Would that be my total cost? No, because I also have this $12,750 that no matter how many CDs I make, that has to be paid just to go into the studio to make the original one. What if there were 100 copies that I made? Then I'd take $1.50 and multiply it by 100, and I'd still have to add in that $12,750. If this is not clear enough, we can try one more example. But most can start seeing that there's a pattern here. I'm going to have this fixed cost of $12,750, and then I'm going to take my number and multiply it by $1.50. So if I have T CDs, it'll be 150 T plus 12,750. So now let's define our variables. It actually is, the T is pretty much defined in the problem. Let T equal the number of CDs. C of T is the total cost. So if we let this equal C of T, this is function notation. It doesn't say multiplication. It's saying C of T. This is like your Y variable. So we've done that now. Now let's take a look at our revenue. So there's A. And then B. And I think I left off part of the problem, but B will be the revenue if I sell 0, then I make 0. If I sell 10, then I'm going to make $10 each. If I sell 100, I'm going to make 10 times that. Now note, one thing I didn't say thus far is, notice here that I didn't actually write down the total value. The only thing I wrote down is how to compute it, because that's really what we want to know in writing the equation. If we just wrote this total value, what would that be? 12,765. That's really not showing us anything for writing the equation. That's just giving us a couple random numbers, which we would have a very difficult time trying to write the equation of. Similarly over here, I have T that I'm selling. and well, I have just number of CDs I'm selling, so it'll be 10T. So my revenue cost, and we'll let R of T equal the total revenue. Now we have 10T equals R of T. State the domain and range. What is the domain going to be? Now we're not getting too heavy into this right this moment, but domain is all the values of our independent variable, all the values of the variable that's changing first. So the number of CDs that's bought or sold is changing, and then we know how much we have to pay or how much money we're bringing in. What can you say about T? Can T be a positive number, 0, a negative number? Well, it can't be negative. You can't sell a negative number of CDs or make a negative number of CDs. You can have 0. You can sell or 0 CDs. Can we have 1.5? No. So the domain would be T has to be a whole number. And then C, let's just look at the domain of the cost function for right now. The cost C of T, well, C of T, the minimum cost is going to be $12,750, and it can be greater than that. And there's a little more specifics we could get into, but for where we're at right now, this is enough. Let's add in a part D that I did not write down here. At what point, let me just, that's fine. At what point do they start making money? Sketch the graph. Notice at the bottom of the page I have a XY axis set up, or in this case we don't have X and Y. We'll have T, and we'll have basically number of dollars. We're not going to graph it exactly. What we really want to look at is a rough idea of what's going on. When we look at our cost function, we have a y-intercept of 12,750. We could look and put it in terms of thousands and just say 1, 2, 3, 4, 5, and we'll label every 5 of them. 6, 7, 8, 9, 10. There's 10,000. 11, 12, 13. So we're going to start off close to that 13. It doesn't have to be exact. What kind of slope do we have here? 1.5. Well, it's a positive slope, and really we don't care about the slope itself. We're going to draw it relative to the 10t. So when we look at a 1.5 versus 10, how does 1.5 compare? It's going to be flatter, and the 10t will be steeper. So if we just do something like this, now when that's our C of t. Revenue, if we have 0 cells, then we have 0 that we're taking in. It has a steep slope, and they're going to intersect at some point. How do we find that intersection point? What is the t value for that? How do we solve this? We've done this before. This is a system of two equations with two variables. We have c of t equals 1.5t plus 12,750. R of t equals 10t. At that point of intersection, what can you say about the cost and revenue? They're the same. So we could do substitution in this case and say 10t equals 1.5t plus 12,750. Subtract the 1.5. 8.5t equals 12,750. Divide by 8.5, and we get 1,500. So we come back here and say at 1,500 CDs, they will break even. We could find what's the cost, or what's the cost or revenue, how much money at that point. Which of these two equations would you use to find how much money? At that point, the cost and revenue are, the easiest one to use is a revenue, so it's just going to be $15,000.